When we're looking at populations and samples, oftentimes we take a sample of a whole population and we ask them some questions and we get data out of that. And you take that data and that is then used to answer statistical questions. Now, when we get data from a whole population, we call it a parameter. When we get data or a number from a sample, we call that a statistic, which is now you understand where the name statistics comes from. Because typically we're very, very, very rarely looking at a whole population. Very rarely can we ask the entire population of something. Ask all of the population of a group of people an answer, or test every single widget that comes off the production line. But oftentimes we just test a few of them and we assume that the whole population shares that trait. So a parameter is a number that we get from a population. So if I asked every single person in our high school how tall they were and then use that to calculate a number, that would be a parameter. But if I asked 20 people in our high school how tall they were and used that to calculate a number, then that would be a statistic because it's a number that's calculated from a sample. So let's look at our examples. Mrs. Barney's curious about the highest math class that her students will eventually take. So if I looked at all of my students and asked every single one of them, then I would be getting a parameter. But since I looked at just 45 of them, I got a statistic. Same with the marriage counselor. The 50 couples that are her sample, their percentage of couples that stayed married is a statistic, not a parameter. A parameter would be if she asked every single couple she has ever counseled whether or not they stayed married and found like a percent from there, that would be a parameter because it came from the population. So this one again, 750 people, say 50% of those people said they were going to vote for this candidate. That would be a statistic because it came from a sample. But the number of people who did vote for the candidate, like in the end, if we just added up everybody who voted for the candidate, that would be a parameter because it came from a population. We took every single person who voted and we found whether or not they voted for this candidate, and that would be a population. So data we get from a population is now a parameter. What I love about this one is it actually works because their population and parameters start with the same thing in statistics, and samples start with the same letter. So it's really helpful because often in math it doesn't work that way where we get this like word that doesn't seem like it should fit and it does. So yeah, if you just remember population, parameter, statistic, sample. So again, the statistic would be for the coffee shop, that would be the average wait time before they left. That would be a statistic. If we're just talking about the people who he looked at, the 25 people. If we counted every single person in our population and found that average wait time, that would be a parameter. The average recovery time for the 32 patients would be a statistic. And then if we were able to measure the average recovery time for all patients that she's ever treated, that would be a parameter. The number of out-of-state vehicles that we took from this sample would be a statistic. The parameter would be if we looked at, if we counted every single vehicle in the entire population and found how many of them were out-of-state vehicles. And finally, the parameter for this one would be the tensile strength of every single threaded rod that was created if we were able to test that. But the statistic comes from the sample, which means that it's the tensile strength of the 40 threaded rods that we actually picked.